Okay, Assalamualaikum and good day. So, hari ni saya akan sambung dengan lecture yang sama, lecture 3. Tapi kita akan sambung part yang sampai hari tu. Okay ya? Okay, so for lecture 3, we are discussing normal distribution. Betul tak? And then we learn already about the what is the normal distribution and how to standardize, and also find the probability using the standard normal distribution table. Okay, now we continue with which part? So let's see here. We've discussed up to example 2, also have discussed example 4. Okay, so we need to continue at example 4, right? Okay, so now for example 4, it's given that x following a normal distribution with 10 and 25 as the parameter. So what is this 10? This 10 is the mean. This 25 is sigma square. Now we want to find the value of a if probability of x is more than or equal to a, which is equal to 0.1151. Okay, so do you still remember how do we find out the value of a for binomial and Poisson? So it more or less like that, like in binomial and Poisson. The difference is that for normal, we don't have to care whether it has a equal sign or we don't have equal sign. Okay, so let's see for question A. So probability of x more than or equal to a is equal to 0.1151. So because we don't have the table for this mu and sigma square, so what we need to do is to standardize. So how to standardize? So we use the formula of z equal to x minus mu over sigma. So because our mu is equal to 10, our sigma square is equal to 25. So the z is more than or equal to, so this a will change into a minus 10 divided by square root of 25, and it's equal to 0.1151. So what do we get from the table? Okay, so we can see that this z value is actually on the right side of 0. Why? Because this probability, because we have z more than, we want to take the right side of z. And then this value is less than 0.5. So it will be on the right side of z. If we assume that this z is on the left side of 0, then the area on the right side of z will be more than 0.5. Because it's less than 0.5, so this z should be on the right side. So we have to make sure that we put the value of z on the correct part. Okay, so now we know the z is on the right side, then we can directly conclude that this we can directly conclude it will be on the right side. So this is smaller triangle, so we can directly compare the value of 0.1151 and with the one from the table. Okay, so from table, okay, we can check that probability of z is more than 1.20 will be equal to 0.1151. Okay, if you want or if you want to check, so let's check the table together. Okay, so let me check the table together, or you can open your table. Wait, so we want to check the table. So this is our table. Wait, sorry. So for the standard normal distribution table at page 21. So 0.1151, where is 0? Yes, this is the 0. 0.1151 is here. Okay, So this is 0.1151. So we can see that it's directly the 1.20 value. Okay, so we can say that probability of Z more than 1.20 is equal to 0.1151. So everything is the same except for this part, right? So we can just compare this part. So A minus 10 divided by square of 25 is equal to 1.2. So then A will be the subject. We get 1.2 multiplied by 5 plus 10, which is equal to 16. Okay, so we get A is equal to 16. Okay, now let's see example B. So probability of X is less than or equal to A is equal to 0.1151. So we have the same value now, 0.1151. So what we need to do, because it's a normal distribution, we need to standardize. First step is to standardize. So after standardizing, we get probability of Z less than or equal to A minus 10 divided by square root of 25 is equal to 0.1151. Okay, so where is this Z located? Okay, this Z is located on the left side of 0. Why? If we put Z on the right side of 0, so the area on the left side of Z will be more than 0.5. But what we have here is lesser than 0.5. That's why we can put Z on the left side. So this is only logic. We use the logic. So if Z, this part is actually less than, we cannot directly check from the table. What we need to do is to reflect. Okay, so to reflect, it will be on the right side. Reflect on the X equal to 0 here. Then we can get from Z, it will be negative Z, and it's more than. Okay, so we get probability of Z is more than a negative of. So it's negative of everything here. So negative of A minus 10 over square root of 25 is equal to 0.1151. And we know from table that probability of Z more than or equal to negative 1.20, which is equal to 0.1151. So we need to compare everything here, which is negative of A minus 10 divided by square root of 25 is equal to 1.20. So negative, we can bring it together with this square root of 25. So it will be negative 5 here. So 1.2 multiplied by negative 5 is negative 1.2, negative 5, negative 6. Okay, so negative 6 plus 10 is equal to 4. Okay, A minus 10 is equal to negative 5 multiplied by 1.2, which is equal to negative 6. So A minus 10 is equal to negative 6. So A is equal to 10 minus 6, which is equal to 4. Okay, so if we relate back with our normal distribution, we will have a bell shape with mean in the middle. So 4 will be on the left side of 10. For question A, we have 16. 16 is on the right side of 10. Okay, so it is correctly put lah. So we have the correct value for A. Now for question C, probability of X more than or equal to A is equal to 0.8023. So what do you think about the value of A? Or actually after the standardizing, it will be A minus 10 over square root of 25. Is it on the left side of 0 or on the right side of 0? So let's say we assume it's on the right side of 0. So this is Z. Okay, so we want to take the area on the right side of Z. This is really small, right? The biggest one pun, we have 0.5. But here is more than 0.5. So actually, our Z is more than, is on the left of 0. Okay, so if we have the less of 0, what do we do to get this one? So we need to find the complement. So we need to subtract the smaller triangle. Okay, it will be 1 minus probability of Z less than or equal to A minus 10 over square root of 25. And then we don't have this left side of Z on the left side of 0, right? So we reflect. Okay, this is actually z less than or equal to a minus 10 over square root of 25 is actually equal to z more than negative of a minus 10 over square root of 25. Okay, so we rearrange this part. Okay, so we get 1 minus 0.8023. 8023 is equal to probability of z less than equal to a minus 10 over square root of 25. And then because this value is the same as z more than negative value, then we can compare from the table. Okay, so from table, what do we have? We can have the value of z more than, from table is actually 0.85, that we have the probability 0.1977. So compare this value. Okay, compare this value, negative of a minus 10 divided by square root of 25 with 0.85. So we will have a equal to 5.75. Okay, and then question D. Probability of x less than or equal to a is equal to 0.8023. So where is this a? So probability of x, first of all, we need to standardize. So z will be less than or equal to a minus 10 divided by square root of 25 is equal to 0.8023. So this z is actually on the right side lah, because the area on the left side of z is more than 0.5. Okay, so we just directly find out what is this z by, comparing to the table, but we need to subtract by 1. We have to take the complement because we only know the area for the smaller triangle. Okay, so 1 minus probability z more than or equal to a minus 10 over square root of 25 is equal to 0.8023. Okay, then probability of z more than or equal to a minus 10 divided by square root of 25 is equal to 0.1977 after we subtract this value from 1, right? So from the table, we know that probability of z more than 0.85 is equal to 0.1977. So compare these two value, a minus 10 over square root of 25 is equal to 0.85. So a is equal to 14.25. Okay. Okay, now let's continue with the next example. So this is actually the problem solving example. So marks obtained by student in a mathematics test are normally distributed. So it's given here, normally distributed with mean equal to 68 and standard deviation is equal to 5. Calculate the probability randomly selected student obtained less than 58, more than 75, between 62 and 76, and between 70 and 80. Okay, first of all, what is the step that we need to do if we have a problem solving question? First of all, we have to define, as usual, we have to define the variable. So we let x, the variable, as the marks obtained by student in mathematics test. So this x will follow the normal distribution with 68 as the mean and 5 as the standard deviation. So the parameter here will be 68 and 5 squared. Okay, why square? Because the parameter is the sigma square, not sigma only. Okay, it's a variance. Now, to find the probability for x less than 58, so we apply the formula z equal to x minus mu over sigma. So probability of x less than 58 is equal to z less than 58 minus 68 over 5, which is the standard deviation, the sigma. So we get probability of z less than negative 2. So if we draw the bell-shaped graph, so negative 2 will be on the left side of 0. So what we want to find is less than negative 2. It will be the area on the left side of negative 2. So we cannot find it by using table directly. So we can reflect on the right side. So from negative 2, it will be 2 and it will be more than. So it's the same as probability of z more than 2. And then from table, we know that for the probability will be 0.0228. Okay, now continue with question B. Okay, so probability of x more than 75. Okay, first step is to standardize. If we have normal, then we have to standardize. So first step to standardizing, apply the formula z equal to x minus mu over sigma. We have 75 minus 68 over 5, which is equal to z more than 1.4. So for this value, z 1.4 is on the right side of 0. So the area we want to find is on the right side of 1.4, which is the smaller triangle that we can directly compare with the table value. So from the table, we have probability equal to 0.0808. Okay, so this is easier. Question B is easier than question A. Directly we can take from the table. And then for question C, probability of x in between 62 and 75. So standardizing, we get probability of z in between -2 and 1.6. So where do we have this area? So our bell-shaped graph here with 0. So -1.2 is on the left side of 0. 1.6 is on the right side of 0. So how do we take the probability in the middle? So we will take out the smaller triangle. So this triangle, we know directly it's probability of z more than 1.6. But for the negative one, less than -1.2 is the same as more than 1.2, positive 1.2. Okay, less than z less than -1.2, we change the direction, we change the sign. Negative to positive, less than will be more than. So z more than 1.2. So take the value from the table for both 1.6 and 1.2. We get 1 minus 0.0548 minus 0.1151, which is equal to 0.8301. And example D. So probability of x from 70 to 80. In between 70 and 80, first of all, standardize. Use the formula. We get the probability of z in between 0.4 and 2.4. So on the bell-shaped graph, so we have 0.4 and 2.4 both on the right side of 0. So to get the area between 0.4 to 2.4, we take the bigger triangle, subtract the smaller triangle here. So what is the bigger triangle? It's probability of z more than 0.4 minus probability of z more than 2.4. So use the table, we get 0.3446 minus 0.0082, which is equal to 0.3364. Okay, so this is for example 5. Now for example 6. A random variable has a normal distribution with standard deviation sigma equal to 10. Find its mean if the probability that it will take on a value more than 77.5 is 0.1736. Okay, now we don't have the mean, but we have the probability for x more than 77.5. So we take out all the information. X is a normal with mu as the mean and 10 squared as the sigma square. Okay, so now we don't know what the mean, so we represent it as mu, and it's given that probability of x more than 77.5 is equal to 0.1736. So what is this x? We have the first thing we need to do is to standardize. So standardizing 77.5 minus mu over 10 is equal to 0.1736. So what is this value of z? Will be on the right side of 0 or on the left side of 0? Because it's more than and the probability is less than 0.5, so it will be on the right side lah. So this z is actually on the right side, so we can directly take this value 0.1736 from the table. So from the table, we can see that its probability of z more than 0.85 is equal to, okay, so there is something wrong here. Oh, okay, let me check. First, 0.1736 from the table. Wait, we need to check from the table. This is the correct, this is wrong answer, not 0.1977, not 0.85. Okay, we are talking about 0.1736. So let's check the table. 1736. 1736 is here. It's 0.94. So we have some minor mistake here. It should be probability of z more than 0.94 equal to 0.1736. So we need to compare 77.5 minus mu over 10 with 0.94. Okay, sorry with the mistake here. So what is mu? So let us calculate together. Let me take my calculator. Okay, so 0.94 multiplied by 10 is 9.4, right? So 9.4 multiply, 9.4 mu 75, 9.4, it's 10 multiplied by 0.94 is 9.4. And then we will have, means that after we multiply by that, it will be 77.5 minus mu equal to 9.4. So mu is equal to 77.5 minus 9.4. 77.5 minus 9.4 is equal to 68.1. So our mu is equal to 68.1. Okay, so sorry for the mistake there. So I think that's all for example 6. I will continue with lecture 4 on the next lecture part. Okay. Okay. Okay, wait. Okay. And broadcast.